Now let's do application questions of length of an arc. So we're going to use the length of an arc formula to attempt some application questions that requires us to kind of solve some problem solving questions. So this time they might not give you diagrams like they did before straight away. You'll have to build up your own diagram by understanding the question first. So make sure you're familiar with this formula here. I won't go through the details again. That's pretty much the length of the arc formula. If you're not really familiar with that, I suggest you to watch the video of length of the arc, the basic ones first, and then move on to this one. Alright, so let's try the questions. Question 1, find the length of the arc at the equator if the angle of 55 degrees is subtended to the center of the Earth. Assume that the radius of the Earth is 6,400 kilometers and correct to the nearest kilometer. Okay, so we've got the Earth here, but what we want to know is the length of the arc that subtends 55 degree angle. So this is the equator, and we want it to subtend 55 degree like that. Okay, so we're interested in this length here. Make sense, guys? And it tells us the radius is 6,400. So this length here is 6,400. So we've got everything. We've got the angle at the center of this sector, and we've got the radius. So to find the length of this arc, we just have to use our length of the arc formula. So 55 degrees out of the full revolution, 360 degrees is the fraction of the circle of this sector, and we multiply it by the circumference, 2 pi r, where r is 6,400. And multiply them all together, and you should get something like that. And to the nearest kilometer, it should be 6,144 kilometers. That's the length of this particular arc here. Make sense, guys? So it's pretty much straightforward using the arc length formula, but you do have to do a bit of reading and trying to draw a picture all the time as well. Question 2, assume that the radius of the Earth is 6,400 kilometers and correct to the nearest kilometer for the following questions. So A, it says find the circumference of the Earth at the equator. Now guys, the circumference of the full circle. So the full circle is 360 degrees. So what I'm going to do is still write this one through, because we always write angle over the 360 degrees. That just equals to 1, so you don't really need to put it there. You just need to use the 2 pi r circumference formula, but I just put it there just to show that it applies to the arc formula as well. So it's 360 degrees over the 360 degrees because it's the full circle. So I just put it there for the sake of that and multiply it by the 2 pi r, the circumference formula. Radius is 6,400. And just multiply it, you should get something like that. To the nearest kilometer, it should be that. Okay, just round it to the nearest kilometer because they want you to put it like that. That's the circumference of the Earth at the equator, the full circle, okay? Now, B, find the shortest distance between 2 points on the equator if they subtend an angle of 10 degrees to the center of the Earth. So if this is the center of the Earth, we want it to subtend just like 10 degrees, so a really small angle there, 10 degrees, okay? And we want to find the shortest distance between 2 points. So this is 1 point and this is another. We want to find this length here. Alright, so again the radius is still going to be 6,400, so let's put it all in. The fraction is 10 degrees out of the 360 degrees. We multiply it by 2 pi r, where radius is given to us, and just multiply it all together. And that's what it gets. And to the nearest kilometer, it should be just 1,117 kilometers. That is pretty much it. So it's always very useful to draw a diagram first. I suggest you to do that even if it looks easy. Now C, find the distance between 2 points on the equator if they are on opposite sides of the Earth. So again, I'll show you in respect to the full circle. That's the equator. So say for example, if one point is here, then the other point must be directly on the opposite side. That's the equator, so it should be right there, right opposite to each other. So if I draw a little line in between, that angle there is exactly a straight line because they're right opposite each other. So that one must be 180 degrees, isn't it? And we want the distance, so we want that distance here. So I'll just call that L. L for length of the arc. So it's going to be 180 over 360 times 2 pi r. Radius is given to us, and just multiply that all together. Or basically you can just multiply by half, which this one is simplified to a half, isn't it? And you should get that if you calculate, and to the nearest kilometre, something like that. So that is the distance between the 2 points, which is pretty much the length of the arc. Alright guys, so as I keep saying, draw a diagram, and it's pretty much utilising that length of the arc formula.